if you will, those two polar bonds are acting like two forces there. If you're pulling towards each other at an angle, you have a net force in it. So the molecule itself, and this molecule is going to be polar. Okay? The water molecule is a polar molecule, which is a very important concept there. That makes ionic compound soluble, many ionic compounds soluble in water, many polar compounds like alcohol soluble in water, because like dissolves like. That's a statement that we use and something that we will look into in chapter 11, chapter 12. And because of the intermolecular forces there, when you have two different chemicals mixing with one another, the molecules will be able to interact with one another if they have a similar type of bound or intermolecular forces. Okay? Oil, we know, do not mix with water because oil molecules, gasoline or cooking oil, those molecules, they have different type of intermolecular force compared to the water. Okay? So water is a polar molecule, and those oil molecules are nonpolar. Polar and nonpolar, they won't mix. But if you have alcohol, alcohol is a polar molecule, water is a polar molecule. Well, talking about alcohol, low molecular weight alcohol, ethanol, methanol for that matter, propanol as well. Those molecules are polar, water is polar, so you can mix them together and they can dissolve in one another, which is probably a good thing. Otherwise, you wouldn't have that alcoholic beverage there if alcohol is not dissolving in water there. Okay, so when you have polyatomic molecules there, determining the polarity of the molecule, you have to take into the geometry into consideration. Okay, so that's about the as much as we want to get for the first part of the lecture there, and we will take a short break, and then after we come back from the break there, and we will continue the discussion. There's one more learning objective to go for this chapter there. So let's take a break, and then we'll come back and we'll continue this discussion.
That's why I can come in the morning. I started working at a camp on Sunday. Okay, like I can miss the first day.
Oh yeah, no problem.
Cool. I'll remind you on Thursday. So.
Yeah, but send me an email. Okay, I'll try to remember.
Yeah,
I
I'll send
can't
you an
get
email
it.
later.
Yeah, send me an email and then I will put it in. All right, then you can go there. So as long as you get there by 5.
Okay. Yeah, I'll just come in the morning.
Okay.
Thank you.
I'll write it down. When you try to make predictions, yeah, that's right. What we're comparing here is that we have this and this. Okay. Now, according to the, well, they are not in the same group. They are not in the same unit either. So if this is here, we can say, well, this one, in terms of ionization, top to bottom is getting smaller. So this one will be lower than
Did you do the
this.
quiz yet?
This one will also be lower than this because we go to left to right. It's increasing. So this one is lower. Well, this one is lower than this. This one is lower than this. We can't really count which one is. When you make a comparison there, you got gotta be able to, if A is greater than B, B is greater than C, then A is greater than C. That kind of relationship. In here, we don't have that kind of relationship. Therefore, we can't really simply by looking at same here. Say if you're comparing these, they're in the same. But if you're comparing between this and this, okay, this is lower than the.
And then you have to solve for
Comparing this with this, they're not in the same group. Okay, this one is lower than this. This one is lower than this. So this will be the highest. This one is lower. Okay, so if this is lower than sulfur, this is even lower than selenium, then this has to be lower than this. This is a situation where you can. But for this particular situation, this one is lower than this. This one is lower than this.
Yeah.
Higher than that. Higher than that. So yeah. There's also a transition situation because you're getting, this is the group 6A. I mean, this is the period number 6. And they are really getting more of an balance in both top to bottom here. So this answer, according to what we're talking about here, this is higher than this. This is, well, yes, this is higher. This is higher. We can't really higher. Because it's the same situation. It's not the same situation as compared to this. So more than often, we make predictions based solely based on where they are in the behavior. Yeah. Cannot be determined because this is higher than this. This is also higher than this. Well, this one in this case, oxygen is an exception because when you combine chlorine and oxygen, it's supposed to be group 7A, it's supposed to be negative next to group 6A, but that's an exception. That's one of the exceptions. Yeah. So, and all of these though, when we ask you to do the practice there, and some of the homework actually takes into consideration of the exception. But, as long as you know, there are exceptions to the GR trend. Right. Right, when you're doing the electron integration, there are always exceptions. Same thing happens for the GR trend. So, when you look at the GR trend, talking about the ionization energy, if you look at one of the ones that I have here, some columns is in the middle, but it's actually sunk down a little bit. And in general trend, it's supposed to go up, but there is one group in there that actually is lower. So there's always those exceptions there. And we are not going to testing you on exceptions there when we do homework since it's open book.